Good morning. My name is Mikael Jonsson and I'm the product manager for a test suite called Cantata. I welcome everyone to this meeting, and I will also start with introducing my colleague Martin.
Hello Mikael, thank you. My name is Martin Andersson. I work as a team leader here for know-how support.
And today the object is to talk about unit test. That can be quite laborious and, in my opinion, a little bit tedious. I don't know what you say, Martin.
I disagree a bit, but we will see later on.
Anyway, we will talk about how we can do it easier and faster and less cumbersome to generate tests for C and C++ code. And we will focus on a product called Cantata from QA Systems. And the intention of the product is really to make our life easier when we're developing, executing, and reporting on our tests. The agenda today is covered soon here. I'll just mention that Cantata is used by thousands of companies around the world. That was the point of this slide.
Yes,
Martin.
exactly.
Still early day.
Yes.
Here we're coming to the agenda.
Yes.
Yes. First, I would like to define what we mean with unit and integration test, as there are often different opinions about what we mean. But we're focusing on software side, and we'll talk about that. Next thing is, how can we generate easily the tests that we need to execute, and how do we execute them, and how do we know on the next point when to finish testing? How do we measure the quality of our tests? When the tests are good enough, we can stop testing. And we've stopped testing, we have the tedious work of reporting what we've done. Documentation. I don't know many people that love documentation. So we'll have a look at how we can make things easier regarding those things. And for very many of us that are working with functional safety projects and have regulatory requirements to create traceability between our requirements and tests, we'll show you also how we can facilitate those tasks. And finally, tests, we don't want to run tests manually, we want to automate them, and we'll show how you can integrate testing into your continuous integration process, whether you're using Jenkins or TeamCity or some other CI tool. And I'd like to mention also that we will go through a number of things. You're welcome to ask questions, but we would like you to use the chat window in the GoToMeeting panel to the right of your screen. And also we will answer the questions at the end, right?
Yeah,
Martin?
Yes.
Yeah.
As many questions as possible, or otherwise we'll send you an email.
So basically, before we go into the live show, Martin, maybe we should just define what we mean with unit testing, where we place our meaning of unit testing in the life cycle of software development. So just using the V model as a piece of illustration for this, when we've generated our code, when we've written our code, well, the first things we do is really to compile the code and make sure we have no syntactic errors in it. We want to check that the code works, and what I mean is that the compiler is usually not good enough to make sure that we have really robust code. We need also to run it through some kind of source code analysis tool like PCLint, CodeSonar, QAC, or similar analysis engine.
Yeah.
What do you say, Martin? Is that what's your favorite here?
Well, yeah, I agree. It depends on what you want to look for. If you want to look for the coding rules being correctly followed, or if you want to find bugs. But I prefer CodeToner actually. But that's a bit.
That's your okay. Well, that's not the scope of
No,
today's meeting
sorry.
anyway. But we want to make sure that we deliver robust code to our testing process. And the next step then is, okay, we have robust code, but does it do what we wanted to do? Does it have the functions we wanted to have? So when we're talking about unit testing, you and me, Martin, we mean the lowest level of testing the functional blocks of your software, on function level, on method level, on class level, and then the module integration in the next level. And that is where Kantata comes in. I like just to get the laser pointer here. So when we mean unit test and integration test, we're talking about software only, and with software run at the lowest level, but run on host or run on target. And that's when we dynamically test the code. So then we come to the critical question of when can we stop testing? When have we tested enough? Because we all know that we can test forever, and there probably will be some problems left in the code anyway. The silver bullet here, if we want to call it that, is to measure the coverage of the tests in your code. How much code has been executed by your tests? Is it 50%? Is it 100%? What threshold shall we overcome in order to be happy? Well, that's something every organization decides for itself. But of course, if you do have like regulatory requirements, you have maybe the requirement to fulfill industrial standards like 61508, automotive 26262, or similar standards in medical, railway, or other industries, then you like to know that the tools you're using are also qualified and certified for its purpose in those type of applications. The good thing with Kantata is that it has been qualified by TÜV. It's been certified, and you can use it to qualify it in your own environment, in your own development environment, on your own hardware. So that's one nice thing about Kantata. Makes life easier in those type of projects. Of course, no tool works only standalone. We always want to integrate things. And when it comes to unit testing, Martin, what should I think about in terms of integration?
Well, always when working with a tool, you want to work with it, not against it. And one really good thing with Kantata is that it's built up with Eclipse. It has an automatic triggering for static code analysis like QAC. It has a lot of plugins, so you can easily integrate it with your build environment. And of course, it has support for continuous integration and testing. Together with team reporting, it really makes it easier for you to collaborate together with your team. There's a number of IDE integrations where you can use it. You can see here below, or a couple of them. All of this is done to make it easier for you to use Kantata within your build environment.
There are lots of compilers listed here, Martin, but how about if I have a compiler which is not listed?
That's not any problem. You do something called a deployment, and the deployment process is like you are telling Kantata tool how that compiler and linker works, so it knows its limitation, how it's set up. So it's very easy to add different compilers or different linkers if you want to.
Okay.
That's not a problem. Another good thing with Kantata, all of this is done for you to make it more high quality code, more robust code, and taking off the workload from you, auto-generating the test framework for you. That means that you don't have to sit and redo all the work with the test framework over and over again. This is automatically done with Kantata. Kantata, you pass your project code with it, and then it knows what external calls you have from your unit under test and what type of functions you have also. So it's really good and really easy to get up and running with the first test that you create. And of course, it's easy to understand how it's built up. I will show you later on. It's not any magic. There is a graphical view for you that can be easier in the beginning, and there is also a source file editor where you actually edit the source file. That's the test for your unit under test.
I often get the question on what scripting language do we use?
It's C or C++. It depends on what unit you're testing. So depending if it's C, you get a script in C. If you're using C++, then it's C++. It's very easy. As a programmer, you will very quickly get into how it works. Another good thing with Kantata is the view of your external calls from your unit. It's easy to see what calls is made. You can stub and simulate them or do a dynamic testing with the wrappers, and it's also easy to see the call sequence of each call. And you can control them, of course. I will show this also a bit later on. When it comes to simulation, you often use stubs. Stub is when you actually don't use the object you're calling from your unit under test. Instead, you create your own dummy, more or less, and you can check the parameters that's sent to that stub, and you can choose the return parameters from that stub, meaning that you create the stub within Kantata. And if you have to, you can, of course, raise exceptions. Another thing that's unique with Kantata is the wrappers. The wrappers is really a way of intercepting the calls you're making from your source code. If you have your source code here and you call an object and you want to control how your unit is going to react on that called object, then perhaps you want to control what parameters that's sent to that object. You can alter them. You can check what order they've been called in. And you can also check the parameters that's returned from the call object, and you can modify the parameters from it. So you can handle the way that object is called and really stress test your source code or your unit under test to see that it should be working or is working as it should be doing.
Could you give me an example, Martin, on when this is useful?
Yeah, it could be sometimes quite hard to actually do a stub for a called object or really try to alter the call object. Then the wrapper is really good. Let's say you have a type of a queue, you have some canvas or some other queue, and you're calling that drivers to that hardware. It can be really hard to actually replace that. Then the wrapper is really good because you can actually modify the parameters both to the object or after the object to really see how a unit on a test works.
For a specific test case?
Yeah, for a specific test case, exactly.
Okay.
Yeah. And of course, you still have the possibility to do a before replace wrapper, and then it's more like a stub. You really do your own simulation. The typical way of working with Kantata is that you have your unit under test, and you have a number of test scripts you created. Together with the Kantata library, other options or libraries, you can create an executable. You get a copy of your source code, your unit under test that's instrumented for the code coverage, and you build an executable that you run either on your host or on your target. And all of this was built with Kantata makefiles, and that makes it really easy to integrate to your build environment. After that executable has been run, you get a number of ways of looking at the result and also getting reports from Kantata. When executing on target, you develop your executable on your host, you download your executable with the tests on the possible connections you have. Could be USB, JTAG, serial, or Ethernet, and then you run it on your target. You can have either just a simple LED showing if it's pass or fail. You can have a console output, or if you have the possibility to have a file output. And it has very little overhead. And if you don't have that possibility, you can store it on your target memory, achieve that results from the memory to your host, and then demultiplex your result in your host to get the same graphical view as you had before.
Did you mention that we could also execute on host the tests?
Yeah.
Because I know many customers want to run on PC first.
Yeah, of course. You can choose whether you want to do it on your host or on target. It's up to you. It doesn't really matter. Another good unique thing with Cantata is the team reporting. It's a way for your team spread around the world or country or different places to work together. You don't need the data stored on multiple clients. You have all the test data stored on the server, and it's easy for a project manager to have a good overview of the project you have and how the progress is going. If it's going good, and you can see the tests, and you can actually drill down, even down to the source level in the team reporting. You have a flexible web interface that you can drill down to the summaries like a Cantata GUI style. And you have REST IP, and as I mentioned before, it's integrated with Jenkins for continuous testing. Often when you do complex code or you have some source you want to develop, you have the requirements. Better requirements, better code. And you want to have a way of actually connecting the requirements you have for your unit under test to the actual test you have created. As Mika talked before, traceability. Really want to check, have I fulfilled all the requirements I have in my requirement sheet with my code and my tests? And if I have a certain code coverage rule set, of course, that will also be checked. Okay, that was a very short introduction. I will try to show you how Cantata looks and works. So let me see. This is the Cantata Eclipse interface. You can see over here, I have a simple or very simple C project with some small, simple C files. And if we have a look in the C file, I'll show you it's a very simple reverse string. It's a classical reverse string. You put in a string of characters and you return it in reverse. Nice and simple. Normally I would like to build this with GCC. I don't have any main in my project right now. But you can see here I'm using MinGV GCC to build this project. The thing I'm going to do now is to enable and pass the project with Cantata. This question I get here is that if I want to use the Cantata server, the team reporting add-on, the thing I was talking about just before, and I can select a container where I will store the result on my server. So I will just click Finish here. Cantata is enabled on the project. I will pass the code with Cantata. You can see up here, I'm parsing the code with my compiler GCC as before, but now I'm passing it with Cantata. So Cantata knows what functions I have in my project and what external calls is made. The next thing I want to do is to actually generate some test script. I use Cantata to auto-generate my test framework and the test scripts for me. I have a different choice here on what I can do. I can do test case per function or auto test. The auto test is a way of creating tests automatically that will exercise all different paths inside of my code. I'm not going to show that today. Just going to select some code coverage level. As you can see here, I have a lot of different pre-made standards of code coverage rules. I just choose some of the coverage rule sets.
I guess you can define your own
Yes.
rule sets here as well.
Good point, Mika. You can copy those that are available, and you can modify them and create your own depending on how your project looks like.
This one you're choosing here, what does it mean?
This one, it's the DO 178 standard. It's level C. It depends really on my project, what demands on my project.
But what does it do? What are the rules here?
I think it's just decision coverage. It's not that very high code coverage level on level C. But I will alter this later on just to show you how easy it is to change the code coverage level. These are the actual calls to my standard function in MinGV, malloc string length, that Kantata has intercepted. It will automatically select a wrapper, and if I don't do anything, the wrapper won't alter anything at all. It would be the same as calling the malloc or string length. Let's finish. Then I go into something called the test script generator, and you can see up here I have my summary. It's a coverage rule set, entry point, integrated with QAC. And down here, if I just make this a bit larger, you can see here in the bottom, I have some tabs. I have my test cases. The first test case is auto-generated. It's put in some short description, test reverse string, and I have some input. It's the Kantata default value, that's null, and expects a return value of Kantata default value, meaning null. Then I have the control interface tab. You can see the different calls that's made from my unit under test. I can put in some additional global data and initialize them, but in this demo I'm not going to use any of those features. I'm just removing them so I don't get any warnings. Okay. So this is actually the first test. I created a test for my project without actually doing any coding at all. So let's try to build and run this. Select as, run Kantata test. I want the full build. I want to upload my results to the server, and I push run. Let's see, it's working. You can see the console output down here. And those of you that noticed, there was a very simple console output of the actual result here. You can see my test case, my coverage rule set. My test case passed, the rule sets failed. But of course, there is a more graphical view of this project also. So let's have a look at that. This is the test result explorer. Here you can see my project, my first test case, that's this one, how it started, the actual return value and the expected return value. You can see my coverage rule set, it's entry point, statement, and call return for level C at DO 178. Okay, so very simple, up and running, the first test case on my project. I haven't even begun typing anything yet.
But just testing null, that wasn't really a very advanced test, was it?
No, no. Good point, good point. I'm coming to that. Hold
okay.
on. I just want to show you the normal way when you're doing a development. You have the requirements. So I want to import the requirement I have and actually check that I'm mapping the requirement to the different test cases I develop. So let's import the requirements. I have my requirements. Let's show you. Hold on. these are my requirements. Nice and simple. They are from Excel. You could use another requirement manage tool if you want to. You can have DOORS, Polarium, PTC, what else you want to use. But these are the requirements I have. It's in Excel. So let's import them. I have an import button down here. I select Excel as input. I have mappings that I've created before. The mappings means I can select what the name of different columns in my Excel sheet should be mapped to the different tests within Cantata. I won't go into that. It's a bit of a setup. It's not very hard to do. I'll select the requirements I have. There's a worksheet I'm going to use in the Excel sheet. Import complete. You can see down here, here's the requirements that I showed you in the Excel sheet. I can select one or all. It doesn't matter. It's free up to you. I go to the next tab. That's called Requirements Trace. That's a way for me to map the different test cases that I've created to the different requirements that I have. And if I have a quick look at the requirements, you can see here there is one. Input string is null, character of null shall be returned. Great. My first test case already covers that. So let's map that one to that requirement. Fulfill one of these three requirements. Okay, and the general is the 100% code coverage, entry point, statement, decision. I haven't fulfilled that. And my test case isn't set up with that code coverage level, so let's change that. I should have 100% entry point, statement, call, return, and decision. So let's select that one. And then I will use my general test case to actually fulfill that requirement. And I have one requirement left. As you said, Mikael, the null perhaps isn't the best way of testing the reverse string function. Okay, great. Let's create another test case then. It's very easy. I copy the first one. You can see here, that's the first one. I copied it. And then I get a copy of that one. I can enter the name or description, but in this demo, that's not the most useful to see how it works. So let's put in a string, something like that. And then I expect a string like that. Okay, so I created two test cases. And then I want to connect that test case to that last requirement. So let's do that. Okay, now I have fulfilled, or I have connected all my test cases to the different requirements. Oh, yeah, good. I forgot one thing to show you. The last test case I created here, I just want to show you if I enhance this view, and I can show you in the source file editor that there isn't any magic with these test cases. It's done in C or C++. In this case, it's C. So if I have a look here, I try to alter this text here. Perhaps, yeah, like that. And you can see that it will automatically update it in the actual test script. And of course, in the same way, if I change the text in the C file here, it will update the graphical view of that test case. So it's very simple, and you quite quickly understand how the test script is generated and works. So let's close that one again. I will make that a bit smaller. Let's.
So this means that I don't have to use the GUI generator if I don't want.
No, you don't need to do that. You can use the ordinary text editor that you want to use to do all the tests. Okay, so let's build and run these. See how it goes. As you can see here, everything was green. I have my 2 test cases, my coverage rule sets, to see that I fulfilled all the things I have in my project. And if I look at the trace view, I will also see that I fulfilled all of the requirements I had with the test cases and code coverage level that I set. There are a lot of different views inside of Kantata IDE that you can use. There is the coverage viewer that will, if I select the project, will show the code coverage level in the source files. And you can actually jump back and forth between the different failures that you haven't reached the level of code coverage you have. You have the report viewer, where you can actually see the report ready for certification that you can use. It's easy to see it. So there's a lot of views of the different views inside of Kantata. And there's a lot of ways to set up your test cases. You can have table-driven test cases. You can import them by text file or Excel sheets. And there is performance measurement. You can measure the time the test cases takes. So there's a lot of things that I won't go over on with Kantata today. Okay, so with very, very little effort, we have created 2 test cases, and we have achieved the code coverage level that we wanted in our trace or our requirements. Okay, just to show you how easy it is to actually use the wrapper functionality I was talking about before, I will just copy the last one, and I will leave this as it is for now. I will go to my call interface control tab. This is the tab where I can control the calls made from my unit. As you can see here, there are 2 different calls, string length and malloc, and both are set as default. Default doesn't change anything at the call. So let's add a new one to string length and call it wrong length, something like that. Won't have any checkers, before, after, wrapper. Okay. Still haven't done anything with the parameters sent to the call object or from the call object. But let's change something just to show you how it works. So I just created the string length call will actually return the wrong value. Save it. Build and run it. You will see there will be 3 test cases here, and the last one will look a bit strange. Oops, sorry, I made a mistake. In the test cases, I've done a new instance of that call, but in my test case, the last test case, I don't want to use the default call. I want to use the one I've just created. Sorry for that. The wrong length. Let's rerun it.
Martin, it seems you need a test case for your test cases.
Yes, it seems like that. Let's see. Let's clear the project and let's run it again. Obviously made some mistake. Okay, back on track again. Okay, so this is the last and third test case I made, just to show you how easy it is to actually manipulate the string length call I've made. So if we have a look at the string length, wrong length, let's just make this a bit bigger. The string length has a default instance data and the wrong length data that I created. The malloc still just have the default. So now I've altered the return value from string length. So it's returning the wrong length of the string. Just to show you how the wrapper works. Okay. Another thing we was talking about was the integration together with Jenkins. Just to show you, I have Jenkins up and running. The demo is the same, more or less the same project I've been showing you. It's the string length, reverse string, sorry. And it's easy to configure if you want to schedule the build or build now or what you want to do in Jenkins. And I have connected, so I get the HTML test report directly inside of Jenkins. And you can see here on the left side, we have the build progress of that project. And I can click on it to get to the team reporting view. The team reporting view is the way of seeing how the project is progressing. You can see the different builds here of the Jenkins. And if we go into the last build with test reverse string, we can see the test result explorer is the same view, look and view as in Kantata GUI. I have the associated files. I also get the code coverage viewer where you can actually drill down in the source and check what code has been run or not. I have green, it's run, it's yellow, it's partly run, and red, it's not run, and blue is comments. So it's very easy to see how the project is progressing. Okay, that was a very short demonstration of how Kantata builds up and generates test scripts, how you can connect it with your requirements tool, and you can export the results to your requirements tool. If you have DOORS, PTC, it doesn't really matter. And I've shown you the integration with Jenkins and also the team reporting add-on to Kantata to have a better view of the project's progress on the server. Have I forgot something, Mikael?
Most likely, but
probably.
We'll see from the questions later.
Yep. Okay, so let's go back to the PowerPoint. So in version 7, you have the traceability to requirement management like DOORS Polarin, as I'm talking about.
I had a question about DOORS Next Generation. Is that supported?
Yeah. And the team reporting add-on, we have a good graphical overview of the results of your projects. You can even drill down the same way as you have in the Kantata GUI. And of course, integration to Jenkins. You can run everything from the command line if you want to, and you have a good integration to the Jenkins build server.
How about if I use a different CI tool?
Yeah, that's no problem. You can always run it from the command line. So it's very easy to set up. Okay, so this is a short summary. Auto-generating the scripts. I've shown the wrappers, even if I did something wrong there in the beginning. We're talking about table-driven tests.
I had a question there from an audience about parameterized test cases.
Yeah, that's also possible. You can do target to host testing. You get the reports ready for certification. You have integration with static code analysis tool. You can map it with the requirements you have from different requirement management tools, integration with Jenkins, and also in Jenkins together with team reporting have a good project manager view.
So does that mean life becomes easier?
Of course, you don't need to do very much. All of the hassle of creating the frameworks or what you want to use is generated by Kantata. So you actually don't need to do anything of the framework work.
Okay, we coming to the QA part here, I
Yes.
have a couple of questions.
Yes.
How can Cantata handle a mix of C and C++?
That's okay. That's no problem.
That's no problem. When you say no problem, well,
that's possible. I mean, you can mix C and C++ source code, but you can't use Java. It's made for C or C++.
Okay. I know there are special features for testing classes and different instances of objects as well.
Yeah. Let's see. I have a number of questions here. I'll see if I can go over them. If there are different versions of Cantata, well, no, it's...
Cantata, there is a basic license for Cantata, and the only extra is the team reporting feature, which gives you the database server for your all your test information.
And the traceability.
And the traceability, yeah.
Yeah. And that's the mix of C and C++. What's the difference between, let's see, wrapper or fake? Well, the wrapper doesn't exclude the actual called object, if I understand the question correctly.
Maybe we should say a mock or fake is what we call a stub.
Yeah, exactly. So there is differences between those. The stub you cannot have within your project when you build it. The wrapper, you actually need the function that you're going to call, external call, in your project. And you can control the parameters to it and from it.
Imagine, for instance, that you need to test an error handler that wants to react on a bit error on your protocol hardware layer. How do you set up a test case to actually get a bit error that the error handler can be tested from? Well, the way to do it is to use the wrapper, so that the wrapper, the called protocol handler, returns a bit error, whether there is a bit error or not in reality. So in real time and embedded application, the wrapper comes in very, very handy.
Let's see, another question. Can you elaborate the 100% code coverage rule? I'm not really sure how to...
I think the question is, what do we mean with 100% coverage?
Okay.
So maybe if you go back and we show you the various coverage rules.
Yeah, of course. Let's go to the summary. We have a number of different type of coverages. We have entry point, statement point, call return point, the decisions, as you can see, a relation and loop coverage. And these are all different types of code coverage. And if you want to achieve 100% of those, all of those have to be fulfilled to 100%. That means all the code has to be run.
Yeah, and so when we say decision, it means that there can be several decisions on one statement. And if we have 100% decision coverage, means that all the decisions in all statements have to be taken at some point during the test execution.
Yeah.
I hope that answers the question.
I hope that is the answer, yeah. Another question is, will the original string be removed when you disable Cantata again? Well, you can actually choose how you would like to set it up. You can choose either to set up a certain, a start up or setup of your test cases, and you can alter those variables along the way. Or you can have one test case that will just have the original string, and then after that we'll remove it. So it's up to you, more or less. That's the question over again. Let's see.
Yeah. Yes,
how do Cantata map to test-driven development? Well, I have had this question before. It's possible for you to set up the test prior to doing the actual functionality in your source.
What we recommend is that you have a good software specification, so that you define on quite low level your requirements for test. And that's actually what Martin showed here in the requirements view, that we had defined the test cases on a quite low level. We didn't actually write the test cases, but we had defined them on a low level, which made it very easy to then elaborate the test case and show that the requirements is fulfilled.
Correct. There's a question, is it possible to see the evolution of the test results? If you have the team reporting, it's a very good overview how the progress is made over time. So yes. It's another question of different versions of Kantata. As Mika said, there is the base functionality, and that's without the team reporting and the trace. And the version that I used now was 7.1. And there is a question about legacy projects. If you have some, let's talk about legacy projects in general. I see the question is a bit more complex than that. But if you have a lot of legacy source code that you know that really works, and you want to create tests for those, if you do that manual, that probably will be a lot of time.
It's a very expensive operation.
Yeah, exactly.
And you really don't want to do that.
No, and then there's the feature that I just briefly mentioned, was the auto test, where you actually create tests that's exercising the source code and creating tests for those, and you can have those tests for later on. If you want to alter anything in your legacy code and you want to be really sure that you haven't changed the functionality in that legacy code, you rerun all the tests and you can check that the functionality hasn't changed with the auto test functionality. I hope that was clear. Yeah,
the auto test is a kind of cheating, because you can actually, with Kantata, if you have a requirement of 100% statement coverage, for instance, you can actually let Kantata generate all the test cases that has to be executed in order to achieve 100% statement coverage. So Kantata can analyze your code, give you enough parameter inputs, and then OK them to make sure that you have executed all your statements. But that's of course to cheat.
Yeah.
But it can be good to have that set of test cases for your legacy code. So when there are changes made to the legacy code, some of those tests may then fail.
Good. And there's a question about if you have an older version of Kantata and like to reuse the components of those tests, is it backwards compatibility with Kantata? Yes, it is, and we can help you if you have a support agreement with you to get everything up and running again. I can contact you later on.
Another question is regarding pricing model. There are basically two ways of handling licenses in Kantata. You can either have a subscription, an annual subscription, or you can buy a permanent license and pay an annual maintenance and upgrade fee. Then there are floating licenses and there are fixed user licenses. These are the different modes of achieving or getting the Kantata licenses.
Another question is it possible to do target tests with zero-var debug instead of JTAG? Yeah, it's possible to do whatever type of connection you have to your target. It's a matter of setting up the correct interface, more or less. And there's a wizard to help you. And if you have support agreement, we can help you get started with it.
We have used Cantata in small 8-bit projects where you have only had maybe 1 or 2 I/O pins to interface, and that's worked. So there are different ways of doing it.
Another question is target support. Does this cost extra, or is it included in the standard Cantata license? And also, which target does it support? Especially Texas Instruments, DSP.
Okay, I don't have the list offhand if that's supported off the shelf. We support the host machines off shelf, and there are a number of configurations we made for different targets, and there is a wizard to adapt to new targets. So in the package you get, there are only the main targets, but then we have extensive knowledge of integrating to dozens of compilers and dozens of architectures.
Yeah, that's normally not a problem. Another question is, does Cantata work on Linux? Yes, it works on Windows and Linux.
But not on Mac.
No, not on Mac.
There was a question about dynamic updating of requirements traceability.
No, at the moment it's not any dynamic connection. You have to import and export the connections.
But I guess you could include that in your CI.
Yeah, of course. You can do a script that creates and does it for you. So good point. That's possible. Let's see some other questions.
That was a follow-up on the 100% code coverage question.
What is the input and what is the output when setting 100% coverage rule?
I'm not quite sure what's meant with that question. What we do is we run the test cases and we check how much of the code actually has been executed during the test. So if all statements have been tested, then we have 100% statement coverage.
Yeah.
If all statements and all branches within the statements have been taken, then we have 100% decision coverage as well.
Yeah. Yep. And there's another question. How much does Cantata cost?
Well, it depends a little bit on licensing model, but the permanent licenses run from roughly 4,500 euros.
Yeah. What do the qualification kits cover?
The qualification kits for various standards gives you a complete test suite so that you can run the test suite in your environment. Because if you have a regulatory requirement, you have to qualify the tool in your own environment. It cannot be done externally. It has to be done with your computers and with all the software you're running on your computers. So you run the test cases and make sure that the results are the ones that is to be expected. When you've done that, you have verified and qualified Cantata in your environment.
There's a question, in what range is the price? A 50 floating license.
Well, we can go into more pricing discussion. Please send us an email and we will contact you and go through your specific setup or license requirements.
There is a question about, can a target test be run in a simulator like ERC SPI simulator instead of a real target? Yes. If you have like ERR or as your normal build environment or Kyle, where you have the possibility to run your actual target as a simulator, then it's possible.
Yeah, we've done several
Yes.
configurations like that.
Yes.
Next question.
Does Cantata support equation partitioning and boundary value analysis? Yes, it does. It actually has some optimizing features to really, if you have, let's say, like a table-driven tests or how to put it up, you set up test cases within ranges, and you create all of those tests, and you have an optimizing feature in Cantata that actually selects those test cases that actually
makes most sense.
Yeah, makes most sense, or its boundaries more or less. Yeah, there are a lot of things or features in Cantata to do different type of analysis. If re-importing requirements, do you need to remap everything to the test cases made previously mapped? Actually, the mapping is stored on the Cantata server for that project. So as long as you don't change the requirements, there shouldn't be any problem. Okay. That was all of the questions we had.
Yeah, I think we've been through them, and yes. Very happy for you to have attended this presentation. And as I said, please get in touch, and we'll help you evaluate Cantata if you wish. We'll help you with support questions you may have, and pricing information, of course.
Yeah.
Thank you, everyone.
Thank you, Michael.
Thank you, Martin.
Thank you, everyone.
Have a good day, and I hope it's a long weekend for everyone.
Thank you, and good day.
Yeah, thank you. Bye.
Bye-bye.